Hi everyone! So for part of our homework today, I wanted us to go through another real-world application of adding rational expressions. And this is actually something that came up in my life recently. So my parents just got a pool in their backyard. So now when I go home, I can go swim in a pool, which is really exciting. But once you finish a pool, you have to fill it with water. And it's up to the person who owns the pool to fill it. And the way that you fill pools is with these big pipes that just kind of gush water into the pool for a couple hours. And my parents actually asked me to kind of help them determine which option is going to be cheaper in the long run. They can either just use one pipe or they can use two pipes working together. The only pipes available at Home Depot worked at different rates because they were different sizes. So we were just kind of doing this math problem, and I realized that it totally matches what we were learning in class. So we're going to work through a situation similar to the one that they had to deal with. So we have one pipe that can fill a pool 1.2 times as fast as another pipe. So there's two pipes here. One pipe is a little faster, one is a little slower. If both pipes are opened, so if both pipes are working to fill a pool, they can fill it in 5 hours. Whereas if you have just one pipe doing it, it's going to take a little bit longer. So what I need to figure out is how long is it going to take to fill the pool if only the faster pipe is used. And then just as a side note, we'll see how long it takes the slower pipe to do it. Because renting two pipes is really expensive. And so if it ends up being somehow cheaper to just do one pipe, we're going to do that. So this was just one of the factors I had to include. And in order to solve this problem, we're going to do something similar to what we did in notes today. So we're just going to kind of make sense of this problem, write some variables, and we'll get going from there. So I see immediately that there is some important information. We know that one pipe can fill a pool 1.25 times as fast as the second pipe. So our faster pipe is filling the pool 1.2 times faster than our slower pipe. And then when both pipes are opened, they fill the pool in 5 hours. So these two pieces of information are going to help us get started and get set up. I'm actually going to let x equal the time that it takes the faster pool, or the faster pipe to fill the pool. So x equals time for faster pipe. And the reason I'm using the faster pipe as our x is because then it becomes really easy to write an expression for our slower pipe. So if our faster pipe takes like 8 hours, our slower pipe definitely needs to take longer. In fact, it needs to take 1.25 times longer. So 1.25x is the time it's going to take the slower pipe. So time for slower pipe. If you initially read this and you wanted to swap those, just think about time. If your faster pipe is x, your slower pipe should have a bigger number next to the x. If we had swapped this, this would have been saying that the faster pipe takes longer. So that doesn't really make sense. And since we know we're going to be working with fractions and adding rational expressions, I kind of want to convert this 1.25 into a fraction. So 1.25 is the same as 5 over 4. And that x is going to stick with us in the numerator. And then the last piece of information we had was that total it takes 5 hours. So 5 equals time for pipes together. Okay. And this is really the main pieces of information that we need in order to get started, because what we get to do now is exactly what we did in class. We're going to make rates for all three of these situations. So for this faster pipe, I know it can fill a pool in X hours, so my rate is going to be one pool every X hours. For my slower pipe, I know I can fill one pool every 5x over 4 hours. And so you have to be a little careful here. Here we're doing 1 over, or 1 divided by 5x over 4. And if you remember how we multiplied and divided rational expressions, all we have to do is flip this second fraction and multiply. So what we'll end up with is 4 over 5x. So that is the rate for my slower pipe. So these are my rates in purple. And then together we know that both of the pipes together can fill 1 pool every 5 hours. So I'm going to do 1 over 5. My fast pipe can fill 1 pool every x hours. My slow pipe can fill 4/5 of a pool every x hours. And my pipes together can fill 1 pool every 5 hours. Which also makes sense, because if you're looking at the rates of the slower versus faster pipes, the slower pipe can't fill a whole pool in the same time that the faster pipe can. The faster pipe can fill 1 whole pool in x hours. This pipe can only fill 4/5 of a pool, which isn't quite an entire pool. Okay, so now we're going to take our rates and we're going to write an equation. I know that the rates of my pipes together will equal the rate of the pipes together. So the rate of the faster pipe plus the rate of the slower pipe, that's going to equal the rate of my pipes together. So now we just have to solve this equation. 1 over x plus 4 over 5x equals 1 over 5. I'm going to do method 2 since we did method 1 in class. So using method 2, we want to find a common denominator for all 3 fractions. So common denominator. Looking at these 3, I can see, okay, well, they all need a 5 because there's a 5 in these 2 denominators. And then we also need an x because there's an x in these 2 denominators. So I got each piece of each denominator included. So now in order to get everything to have the same denominator, I need to multiply 1 over x times 5 over 5. I don't need to do anything to this 4 over 5x because it already has our common denominator. And then I need to multiply 1 over 5 by x over x. Multiplying that all out, I'll get 5 over 5x plus 4 over 5x equals x over 5x. Everything has the same denominator now, so we can add this left side. And what we end up with is 9 over 5x equals x over 5x. And here's where method 2 is really nice, because method 1 you have to cross multiply, but here, if you look, our denominators are exactly the same. And we have an equal sign in between these 2 fractions. So if the bottom needs to equal the bottom, then the top needs to equal the top. So that's where method 2 is kind of cool. You can kind of just ignore the bottom part of the fraction since they're already identical. So therefore, we know that our answer is x equals 9. I would expect 9 over 5x to equal 9 over 5x. And so we go back and we say, okay, well, what did 9 mean? X was the time for our faster pipe, and our question asked how long would it take to fill the pool if only the faster pipe is used. So we answered our first question. Our faster pipe would take 9 hours to fill the pool, which isn't a bad rate considering that together it took 5 hours. So this is our faster pipe. And then the second question asked, how long would it take if only the slower pipe is used? So here we have to go back and see, okay, well, the time for the slower pipe was 1.25x. So what I need to do now is take 1.25 times my x, which is 9. 1.25 times 9 is 11.25. So it would take 11.25 hours for the slower pipe. And so we've answered both of our questions here. We found the rate of the faster pipe, we found the rate of the slower pipe, and we also already knew the rate of the two pipes together. And so when I was doing this with my parents, the faster pipe cost a little more, the slower pipe was a little cheaper, but when we took into the fact the cost of electricity for having a pipe flowing for so long, that kind of helped us determine whether to just get the faster pipe, whether to just get the slower pipe, or whether to get the two pipes together. So this can definitely pop up. If you're planning on working in construction, this is going to be a really useful tactic. And let me know if you have any questions. Have a good day. Bye.